Hey guys, this is the help video for the multi-rep functions assignment. We have 7 problems, and for these slides, you're going to be given a verbal description of a situation. We're going to use that information to then create 3 representations, a table, an equation, and a graph. All right, let's get started. Here's our first one, number 1, verbal down here in the bottom right. A music subscription service charges $6 per month. A music subscription service is something like Spotify or Pandora or Apple Music, that type of thing. And they're charging you $6 a month. Now, when you see this, this word here, per, that is a sign for your variable. Okay, that's a red flag for your variable because we don't know how many months. That's 1 month. Every month you get charged $6. So is it 1 month or 5 months or 6 months? How many months? So when you see that per or for each month, same thing, that kind of indicates that variable that is missing. We don't know how many months. But if we do know how many months, you could then figure out how much your subscription costs. So our algebraic equation is right here. We're still writing our y equals mx, where y equals your slope times x, but they're going to be using different variables to fit our situation. So we have cost C, how much you pay, is what? Our total cost is going to be $6 a month. 6 times every month that I have the subscription. So C equals 6. That kind of looks like a B, but it's a 6M. How much you cost is 6 times the number of months that you have this service. So now we're going to fill in this table here. We can really put any values that we want in this table, but I'm going to make this easy for myself. I'm just going to use 1 month, 2 month, 3, 4, and 5 months. If each month I pay $6, how much is it going to cost me? It's going to cost me $6 for 1 month. 6 times 2 months, that's 12. 6 times 3, 18. 6 times 4, 24. 6 times 5, 30. So we can see how I'm using this equation here. My cost is my number of months times 6 to get my cost, okay? Or my cost is 6 times however many months I want to have the subscription. So my verbal expression matches my algebraic one, which matches my table, and now we have to make a graph that also matches. And actually, on your graph, for some of you guys, I'm going to have this little arrow right here so that you can connect your dots, your points at the end. But if you guys don't have this arrow, then you're going to have to create a line on your slide to connect those points at the end. Now we're going to get these points. These points come from your table. These things that we just wrote out, these are your ordered pairs. Okay, all of this is connected. We're talking about the same situation of a music subscription service for $6 a month. Now, I also do know that if I don't have any months of music, I'm paying $0. So go ahead and drag your first point right there to 0, 0. In fact, all proportional relationships are going to start at 0, 0 because it's not going to make sense for it not to be, right? I can't, if no time passes, my plant's not going to grow at all. If I don't buy candy, I don't spend any money. If I don't have the subscription for any months, I'm not going to be charged any money. All right, now I'm going to fill in these points. These are ordered pairs right here. 1, 6. 1 month costs $6. So drag your next point. 1 month, 1 on the X, 6 on the Y. 1 month is $6 like this. Our next one is 212. 2 months is $12. So plot the point 212. And now we have 318. We have 424. And then we have 5 months for $30. Now, if for some reason you plot these points and it is not a nice line, now plot them as closely as you can. I know it can be a little bit tough dragging that point on your graph, but as close as you can. If for some reason you have a dot that's really far away, like over here, okay, you know that something is wrong, right? We are looking at straight lines that touch our origin. Once you have your points, you're going to drag your arrow if you have an arrow, and if not, you're going to make an arrow that goes from 0, 0 through those points, like a connect the dots, all the way through your last point, like this. All right, mine's a little bit squiggly, but yours should be straight because you're using the arrow tool. Okay, and that's number 1. I'm going to keep on going. Number 2, the cheerleader sells spirit banners for $5 each. You see that word each? Okay, kind of like that word per. Every single banner is $5. So this each tells me that this is my variable. We're going to use our variable B for banners. My earnings, E, will be $5 per banner, 5B. How much money I make is 5 times however many banners I sell. Okay, I'm going to fill in my table now. Let's just make this easy. If I sold 1 banner, 2, 3, 4, and 5 banners. This is multiplication, so how much I earn is just 5 times however many I sold. If I sold 1, 5 times 1 is 5. 5 times 2, 5 times 3, 5 times 4, and 5 times 5. Again, our word problem matches our equation, which matches my table, which will match my graph once I plot my points. Now, if I sold 0 banners, I make $0. So we're going to start at 0, 0, and then we're going to plot these points. 1, 5, so 1 banner X, $5 on the Y. Now, we don't have a 5 on our Y-axis, but we know 5 is between 4 and 6. 2 banners is $10. 3 banners is $15. Again, we don't have a 15, so it goes between that 14 and 16. 4 banners is $20, and we actually don't have enough space. We don't have 25 on our visible y-axis, so we're not going to worry about that last one. Just go ahead and plot these 5 points, and then draw your line, your arrow, going straight through your points like this. It should be a straight line. Plot those points as close as you can get them. All right, I'm going to move on to number 3. The snow is falling at a rate of ½ an inch every hour. There's our key word for our variable, every hour, right? Every, per, each. That's going to be your variable. And our variable this time is H for hour. My equation, how much snowfall is ½ an inch every hour? Okay, so that's multiplication right there. You don't have to put that dot, but half H. Snowfall is ½ an inch per hour for every single hour. Now for this one, I'm not going to do 1, 2, 3, 4, 5, 6. I'm going to try to be smart about this, okay? Because we are talking about halves now. If 1 hour passes, we have a ½ of inch of snow. And I don't really like graphing halves. So instead, I'm going to make my hours, my number of hours, even numbers, because I know that if I have these even numbers, I can cut them perfectly in half. I can split them in half without having to worry about any decimals. But if I try to split an odd number in half, I'm going to then end up with a decimal that I'm going to have to plot on my graph. So I'm going to work smart here. The amount of snowfall is half of my hours. So what's half of 2? 1. What's half of 4? Half of 3, half of 8, half of 10, and half of 12. I'm going to put these on my graph. Of course, if no time passes, I got no snowfall. Now for this one, be careful. It says add a label for the x-axis and add a label for the y-axis. So you're going to have to do a little bit of typing here. My x-axis is going to be the number of hours. Oh, it's not letting me. Okay, I'm going to write it. This is going to be hours. And then over here on the side, it's going to be snowfall. If you want to, actually you should write your inches, your units in parentheses. How are we measuring snowfall? We're measuring in inches. Okay, now we can plot this. In 2 hours, because I skip counted by 2 here, in 2 hours, we have 1 inch of snow. In 4 hours, we have 2 inches of snow. 6 hours, 3. 8 hours, 4. 10 hours, 5. And 12 hours, 6. Now, even if you didn't use these numbers in your table, you went 1, 2, 3, 4, 5, 6, and you have some halves, your line will look the same. Your points will just be in between my blue dots. Okay? You can really put any numbers you want on a table. Though we want to stay low so that these are points that we see on our graph. Number 4, Terry adds $20 to his piggy bank every week. Okay, every week. Weeks is W. So for every W, he gets $20 more dollars. Oh, there's nothing standing right here for our algebraic equation. We have nothing. So his savings, how much money he's saving, and you can see I got this variable up here in this table. Our savings is $20 per week. Okay, however many weeks pass times 20 is how much money he's saving. We can go ahead and change our labels here on our graph. This is going to be the number of weeks that pass. This is going to be how much money we're saving. Okay. All right. 1 week, 2, 3, 4, and 5 weeks. Let's see how much money he saves. In 1 week, he saves $20. 2 weeks, 20 times 2 is 40. 20 times 3, 20 times 4, 20 times 5. We're going to plot these points on our graph. If no time passes, he's got no money, nothing in his savings. 1 week is $20. 20 and 20 is 40. Another 20, 60, another 20, 80, and another 20 is 100. We're up to 100. Connect those lines. Make sure your line goes all the way through, and it also starts at the origin. There we go. All right, number 5. The restaurant goes through 5 jars of pickles every 6 days. All right, this one's a little bit tricky because we're not talking about a single day. We're talking about 6 days. So every 6 days, he goes through 5 jars of pickles. Now, this is not y equals mx. This is 6y equals 5x. Okay, if we're talking about our variables y and x. We want y equals mx. So we're going to use our algebra skills and get this so it's just d equals. In all the previous slides, right, it's just one letter equals something. We don't want the 6. This is multiplication, so I'm going to use my inverse operations. I know this is going to be division. So our equation is d equals 5 over 6j. But I want you to put both of these equations in this blank. I want you to start with 6d equals 5j. Hit enter, and then d equals 5, 6j. So every day, they go through 5/6 of a jar of pickles. Now, don't worry, we're not gonna do this fancy multiplication here for our table. You could, because you get Desmos, but we're gonna be smart about this again. My first value in my table is gonna be what my word problem already told me. 6 jars. Oh, whoops, sorry. That's wrong. 5 jars in 6 days. I'll write it in a different color. Sorry. 5 jars, 6 days. Okay, well, what about 10 jars? How many days would it take me to use up 10 jars? If 5 jars is 6 days, 10 jars is double the amount. 10 jars would take me 12 days. Okay, what if I keep going? 5, 10, what about another set of 5 days? Okay, you can see that we're going to end up skip counting here. And the reason why skip counting works is because skip counting is multiples. You're multiplying. This is 5 times 2 times 3 times 4 times 5. So we're going to do 6 times 2 times 3, Another 5 days is 18, or another 5 jars is 18 days times 4. 6 times 4. And now 6 times 5. Okay, but it all comes back to 6 days and 5 jars. We're going to plot this on our graph here. This is days, and this is jars. Of course, if no time passes, we go through no jars of pickles. And we're not going to plot all of these points because it's not all going to fit on our table here. But I know 5 days. Oh, whoops! I keep doing that. I know 6 days is going to be 5 jars. 6 days, 5 jars right here. I also know 12 days will be 10 jars. That's double the amount. Okay, so we only have room to fit those 2. Now, we could have figured out, knowing this information, we could have figured it out too. We could have butterflied and figured it out too. But we want to work smarter, right? We want to work smarter, not harder. We only need 2 points to make a line. Number 6. Oh, never mind. They just put it off to the side. Okay. So verbal, Amaria earns 3 gold stars in class each day. We have a table still, but it's a vertical table. It's going up and down, which I prefer tables to look like this anyways, because then you can see your order pairs a little bit more clearly. So we have this keyword each. Remember that each? Each day, that's telling us that that's our variable, D. 3 each day. So how many stars she has is 3 a day. My equation is going to be S equals 3D. Number of stars is 3 a day. You can put whatever values in this table that you want for days. 1 day, that's 3 stars. 2 days, that's another 3 stars. So 3 and 3, that's 6 stars. 3 days, 3, 3, 3, and that's 9 stars. And what I'm doing is I'm using this equation, okay? It's going to be the number of days times 3. So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. But I didn't have to use these values 1, 2, 3, 4, 5. I could have skipped all the way to what about in 10 days? 3 times 10, that's 30. She would have 30 stars. What about in 11 days? 3 times 11, that's 33 stars. What about in 100 days? 100 days of school. 3 times 100, that's 300 stars. So you can put anything in that table. I'm just making this a little bit easier for myself. Plus, I want to be able to put these on my graph here. Our y-axis is going to be the number of days over the number of stars. So if no days pass, I have no stars. In 1 day, we have 3 stars. In 2 days, we have 6 stars. And then 9 stars. And then we're out of space here. The next one would have been 12. 12 would have been like right over here. Don't forget about your arrow going through all the points showing that linear function. Straight line. Mine's a little wobbly. We use that line tool. Okay, number 7, last one. A car is traveling a constant speed of 30 kilometers per, keyword per hour. So we know my variable is going to be H there. All right, so the amount I travel, K, is 30 per hour. 30 an hour. Okay, so 1 hour, I travel 30 kilometers. 2 hours is 60. 3 hours is 90. 4 hours is 120. 5 hours is 150. All I'm doing is 30 times 1, 30 times 2, 30 times 3, times 4, and times 5. You are allowed to use a calculator. And let's plot these points, 0, 0. The reason let me show you. The reason I like our tables like this is because you can really see the order pair like this. Right? 130, 260. These are points on your graph. Oh, I forgot to label my x-axis, my x and y. I also realized that this should say x, not y-axis. Okay, this is going to be our hours. And this is going to be our kilometers traveled. Oops. Or you can put distance traveled. Okay, 130. So 1 hour, 30 kilometers. 2 hours, we're at 60. 3 hours, 90. 4 hours, 120. 5 hours, 150. And then draw your line going through. All right, that's it, guys. So the main purpose of this assignment is knowing that there are multiple forms to represent a function. You can show it in a situation. You can have some sort of situation, a word problem, a scenario, put it in some context. But you can show that in using an equation, a table, or a graph, or a graph. So lots of ways to show the exact same situation. All right, hope this helps. See ya.